Very good morning to all of you. The last class we discussed about the stepper motor control. So we have discussed construction, operation of stepper motor, single phase on, two phase on, 2-1 phase on. We discussed, and also we discussed 3-phase stepper motor with the different modes of operation. Now we are going to discuss about the multi-stack stepper motor. Multi-stack stepper motor. So what is a multi-stack stepper motor? Multi-stack stepper motor. Multi-stack stepper motor means the more than one stack in the motor construction. Okay, see here, example. So this is your stator, tube pitch like this. So this is one stack A, this is a stack A, this is stack B, this is here your stack C. Okay, this is a stack A, B, C. But in previous case we studied only one rotor stack with one number of stator slot. Okay, now we are going to discuss multi-stack stepper motor. Multi-stack stepper motor. So this is a definition of the stepper motor. The stepper motor is an electromechanical device. It converts electrical pulses into discrete steps. So electromechanical device means the stepper motor is combination of mechanical and electronics. Actually, the stepper motor is controlled by the power semiconductor switches. These switches are used to energize the phase winding of the stepper motor. Okay, so all these machines, all this stepper motor is a kind of variable reactance motor. All this motor working on the principle of minimum reactance position. Okay. So next one, based on the number of stack, the stepper motor can be classified into two categories. First one is a single stack stepper motor. The second one is called multi-stack stepper motor. Okay, so we already discussed the single stack stepper motor. So for example, the 2-phase stepper motor. This is for 2-phase stepper motor. So 2-phase stepper motor having 4 poles, 4 stator poles. This is the phase A. This is for A prime. This is a B prime. Okay. So we have concentric winding on the stator poles. This means stator poles carrying concentric winding. So this winding connected in the series to form the phases. So like this is connected through semiconductor switches. Like this. This is one phase. Similarly you can form phase B also. Like that, phase B also you can form. You can also connect the switches. Okay. So we have here rotor. Rotor means this is, suppose I have 2-pole rotor. You have two pole. rotor. This is your rotor. So this means only single stack. This means only single stack. In multi-stack stepper motor, each phase having separate stack and separate rotor construction. That is called the multi-stack stepper motor. See here, the multi-stack variable reactance stepper motor has higher torque to volume ratio. Higher torque to volume ratio. That is very, very important. High torque to volume ratio. The compared to single stack variable reactance stepper motor, multi-stack stepper motor offering higher efficiency. This is higher efficiency. This is another one importance of the multi-stack stepper motor is offering higher efficiency. And in this type, each phases having separate stator and the rotor section is called as stack. This means this is one stack, one rotor stator stack, stator stack, rotor. Like that. Okay. So in this type, each phase has separate stator and the rotor section is called as stacker. All the coil in the stator stack are connected in series, and all the poles are facing the rotor becomes north pole or south pole when excited. This is very, very important. We'll discuss one by one now. See, this is the construction of multi-stack stepper motor. See here, first one we draw the stator. So this is one phase of stack, stator stack. We draw a similar diagram here also. So this is one phase of the stator stack. Similarly, you can draw other phase of stator stack. Okay, so it is one phase of stator stack. This is another phase of stator stack. Okay, it is a stack A. It is a stack A. Then stack B, then stack C. Now we have stack A. This is the stack A. We have stack A. We have stack B, and then we have stack C. Stack C. Okay, so all the stator, rotor construction using steel, laminated steel. Here we are not using any permanent magnet. It is also steel. This is also stator stacks also laminated steel. Rotor stacks also laminated steel. Okay, so we have here. This is for. So now this is central point of the rotor. So we have to draw the shaft. This is your shaft. This is your shaft. This is your shaft of the stator. So this is your shaft. Okay. This is your shaft. Okay. So this is your shaft. Now, stator carrying concentric winding on the stator poles. So, and another important, you can say this is a stator A. Sorry, stack A. This is called a stack B. This is called a stack C. So we have 3 stack. So number of stacks equal to number of phases in this case. Number of stack equal to number of phases in this case, so that we have three phases. We have three phases in this case. So stator poles or stator tacks carries stator winding. That winding is called as concentric winding. So this is our concentric winding. This is your concentric winding. So this winding carries the current is called as IA. This is for A phase. Okay. So this is connected the series to another page of stack. Then similarly, we got phase B. So it is also connected in series to other phase of stack. The similar fashion, the phase C. Okay, so this carry current IB. This current carrying IC. It is a phase B. It is a phase C. Okay, so now all other ends are connected to the ground. Okay, so this is for complete construction of multi-stack stepper motor. Multi-stack stepper motor in sense, so we have separate stack, each stack having separate rotor. Okay, so what is the use? So compared to single stack stepper motor, multi-stack stepper motor offer a higher efficiency. The another one on the torque volume ratio is high. Torque volume ratio is high. So okay, so this is for, see here now this is a stator. This is your stator. It is another phase of stator, This is your rotor. This is your rotor. This is sound. This is your sound. Okay. So rotor does not carry any windings. It is made up of silicon steel laminator. Silicon steel lamination. So this is for complete construction of multi-stack stepper motor. Multi-stack stepper motor. We'll see what is next. How to design the multi-stack stepper motor? How to design the multi-stack stepper motor? You can remember the previous slide. So here, let number of stator stack is equal to number of rotor teeth. So we have three stator stack. So we have three here. So we have three rotor teeth. Now another one important point is number of stator teeth for a stack is equal to number of rotor teeth. Number of rotor teeth. Now see number of stack. Number of stacks equal to number of phases. So here we have three stacks. So we have three phases. So three phases. So next one we'll find stator tooth pitch. Stator tooth pitch. Formula of stator tooth pitch is equal to 360 degree upon n. 360 degree upon n. Offset angle formula. Offset angle formula. What is offset angle or step size? Offset angle or step size. Offset angle or step size. So similar to single stack variable reactance motor. So 360 degree upon number of phases multiplied by n. Number of phases multiplied by n. Okay, so this is for basic formulas. From that formula, we will derive what are the requirements. So let's consider n equal to 12. N equal to 12. Tooth slot ratio. Tooth slot ratio is equal to 2:1. 2:1. That means tooth is a 2%, the slot is a 1%. This means this is like this. 2%, slot 1%. Okay, so 2:1. So this is a 2, this is a 1. Okay, so now we calculate. So what is the number of phases? Number of phases equal to 3 because we have 3 phases, 3 stacks. So number of stack equal to number of phases. So we now calculate offset angle or step size. What is the formula? That is equal to 360 degree upon number of pages multiplied by n. So what is that? 12 in multiplied by 3. It is equal to 360 upon 36. So 10 degree. So offset angle or step size for the given data is 10 degree. Now we calculate how to state of the rotor will move one by one. Okay, so slant angle. Now we will calculate slant angle. It is equal to see this angle. Rotor tooth pitch angle. So we calculate stator tooth pitch. That is equal to 360 degree upon divided by 12 equal to 30 degree. So these are the record data. From this record data, we will see how to the rotor stack move for 1 pulses and another stator stack will move, rotor stack will move another pulses, like that we will see. So first we will discuss what is the operation, how it is work. So we have stator, this is the stator. We have stator here, stator. So this is your stator. Okay, this is your stator. So you have rotor. You have a rotor here. Okay. Now the stator. This is your rotor. Okay, stator carrying concentric winding. So this is your phase A, IA, phase A, IB, phase B, similar fashion, phase G, C, IC. Okay, so now this winding is excited by the current pulses by using the transistors, switches. This winding is excited by current pulses using transistor switches. Now, the corresponding for stack A, S1 example, S1 is on. S1 is on. What happened? This winding is energized. Phase A is energized. The MMF is produced in the similar fashion. MMF is produced in the winding similar fashion. Okay, so this MMF align the rotor towards the stator poles. Okay, so similar way here also producing MMF and the stator stack. It is aligned to the stator faces. The similar fashion it is working. Okay, this is a MMF. Okay, so these are the this is operation of the stepper motor. Whenever winding is energized. Okay, so rotor will move. Okay, how to see? We will see now how to see that operation. So we have three stacks. Each stacks having separate rotor sections. So first we'll draw. This is stack A, stack B, stack C. So first total, what is the angle pitch? Angle pitch is a 360 upon N. It is equal to 30 degree. Okay, so total this is the 30 degree. Already told tooth slot ratio is 2:1. 2:1. So this is your 20 degree. It is a 10 degree. So 2:1. Okay, similar fashion here also 2:1. 2:1. So 30 degree. Here also 30 degree. Okay. So this is a stator stack. So this is, we can say, stator stacks A, B and C. Okay. So this is the stator construction. Now we have three rotor stacks: stack A, stack B and stack C. Stack C and stack C. Okay, now see how to stator stack A is moving, stator stack B is moving, rotor stack A is moving, rotor stack B is moving, rotor stack C is moving. What is offset angle? What is offset angle or step size? What is offset angle or step size? So offset angle we already defined the offset angle or step size. It is equal to 360 upon n into number of phases. So offset angle is a 10 degree. Offset angle is 10 degree. So each stator phases move offset angle by the 10 degree. Offset angle by the 10 degree. Okay. Now see how will it will work. We can see draw the line like this. So we have three stator stacks. So we have to now draw. Now see how to draw the rotor stacks. We have three stacks, rotor stacks. So we also will divide here what is angle, offset angle or step size we have 10. So we can use also like this. So it is easy for you for understanding purpose. Okay. So first we will draw the stator stack A. Stator stack A. This is A. It is a stator, rotor, stack A. Now, what is the offset angle? Offset angle is 10 degree or step size is at 10 degree. The rotor stack B is offset angle is 10 degree. So what we'll see, the stator stack B like this, 10 degree. So this is for 10 degree. It will move like this. Like this fashion. Okay? Like this fashion. So this is our rotor stack B. Now, rotor stack C is offsetted by the angle 10 degree again. So it will start from here. It will start from here. So here 10 degree, here we take 10 degree, like this. In this fashion, we are going. So this is for the stator, rotor stack C. So in this fashion, the rotor stacks move, corresponding phases is energized. Corresponding phases is energized. Okay? So this is for complete operation of multi-stack stepper motor. See here. See here. Step angle, first one, steps. The step equal to step, phase A, phase B, phase C. 1, 2, 3 and 4. Okay. Now, phase A is energized, other two phases de-energized. Okay. Now, phase B is energized, other two phases not energized. Now, phase C is energized, another two phases not energized. Next, cycle is repeated, phase A energized, another two phases like this. Now, this is your equivalent circuit. This is the phase A, phase B, phase C. Once switch S1 is on, the base A is energized, the rotor stack A is moving like this, in this fashion. Next, phase winding B is energized. Phase winding B is energized. The stack B, rotor stack B, delayed by the 10 degree offset angle. So it will start the movement from here, 10 degree, like that, 10 degree. So it is a 10 degree delay. So 10 degree offset angle. Next phase C is energized. Another 10 degree offset angle here. It will start from here. So like that, the stator stacks are moving from for corresponding pulses. For the corresponding pulses. So what are the advantages? What are the advantages of variable reactance stepper motor? The last class we discussed a single stack stepper motor. Now we discussed with multi-stack stepper motor. So what are the advantages of variable reactance stepper motors? What are the advantages of variable reactance stepper motor? The low motor inertia. Low motor inertia. Second one is high torque to inertia ratio. High torque to inertia ratio. This is another one important advantages of variable reactance stepper motor. Capable of high stepping rate. Capable of high stepping rate. We have to more stepping rates, more number of steps. So accuracy, more accuracy. When step size increases, we will get more resolutions, more accuracy. So that higher stepping rate. Higher stepping rate. And another one, 3 and 4 and 5 phases, single or multi-stack modes are available. 3 phases already we discussed, 4 phases also we discussed, and also 5 phases also available for single phase and multi-phase, multi-stack model stepper motors. What are the drawbacks? Normally available in 36 to 30 steps angle, low efficiencies of low voltages and stepping rate. This means the stepper motor operate lower stepping rate, so it provides give the lower efficiency. Lower efficiency. If you want higher efficiency, stepper motors would operate high stepping rate. High stepping rate. So minimum stepping rate for the variable reactance stepper motor is about 1.8 steps. 1.8 degree. 1.8 degree. So it means 360 upon 1.8, it is approximately 200 steps. 200 steps per revolution. So like this is there, you can get more efficiency. More efficiency. Okay. The summary of this today class is, we discussed multi-stack stepper motor, number of stack in the stator is equal to number of rotor stack. Number of stack equal to number of phases. So 3 stack means 3 phases. 4 stack means 4 phases. So we can stator tooth pitch is equal to 360 upon n. 360 upon n. Offset angle or step size. Offset angle or step size 360 upon number of phases into n. Okay, so if you want to increase the step size, you can increase the number of phases m. Okay, if you increase the number of phases, you can increase the step size. So stepper motor, the multi-stack stepper motor offering higher efficiency compared to single stack stepper motor. Okay, so next class we will discuss about the permanent magnet stepper motor. In this permanent magnet stepper motor, the stator construction is same as variable reactance stepper motor, but the rotor is a permanent magnet. We already discussed the different characteristics of permanent magnet in the first unit. Now what are the characteristics we are going to we are studying in the first unit, we are going to apply in applications. So in the permanent magnet stepper motor, the rotors are permanent magnet. The stator construction is very similar to the variable magnet stepper motor. Thank you.